So, okay, I'm starting the session recording now. And let me open the links that you sent to me, and let's see. Maybe slightly, I have to open it in another browser. Wait. Yeah. Let me share the screen. Okay. So, Tojo, I think, okay, let me see. Exercise 2. Mhm. Do you see my screen?
So I do.
Okay. So for question 1, I think maybe you didn't answer. Did you?
The answers are there.
No, I cannot see.
They're inside. They're right after the So let's just give an example of a high level program now, which then I wrote Python right after it. For A.
Okay. So okay, let me. Okay. Yeah. So question 1 here. Yeah. So you answered here. Okay.
Yes. Just after.
Okay. Okay. Machine code controls the computer using 1 0. Okay. Yep. Okay. So, but Tojo, let us try to practice that. So try to save the time that we are we are spending here on the class. I prefer that you send to me at least 24 hours before the class, so I can check,
Okay.
and we don't need to waste the time, because I mean, you know that we have a limited time. 1 hour and a half is quite limited, so we need to spend the time properly here. Okay. 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 But did you try to run any code here? I mean,
Yes, I put them here and then ran them as well. You can see it.
uh-huh. Okay, that's interesting. So, okay, let me go and check them. But you already tried them, and it looks like they are working properly, right? Right? Okay. So I would say, yeah. So as with other students, they will always send to me, like I'm telling you now, 24 hours. Are you able to write emails? So are you able to reply me, to give me a reply
Yes, I can.
using an email to tell me that, okay, I already finished the homework. And then
Yeah.
I think if you always save all the exercises in this link, then I'm able to always get the files here, but I need a notification from yours, because I'm not able to always keep checking on my own. So, okay, that works
Yeah.
fine. Okay, that's good. So yeah, let me then stop the sharing, and then okay. Hmm. So Tojo, let me try to understand from you. Did you hear about logic gates before?
Yes.
Okay. So may I know what did you know about logic gates, so I can continue on top of that?
All I know what is that you have and or and then there's also nor and nan, and
Okay.
basically they all like booleans that have different true and false kinds. when you get to them.
Okay. So, okay. Do you know what is the purpose of the logic gates? Tojo, you still with me?
Yes.
Okay. So logic gates, we use it to build control circuits, and the computer from inside is also full of logic gates. Okay. Typically, if we want to design a circuit to control a robot, we will design it using, we will combine many logic gates, and based on the logics that we want to achieve, the control functions that we want to make the robot enjoy, then we will combine many logic gates together to reach that kind of logic that we want to use to control a circuit or a robot arm or any control circuit. Okay, but that will be fixed. Fixed means that we cannot reprogram. So you will combine gates together, combine some of AND, some of NAND, some of XOR, and then once it's designed and it is, you start building with the ICs, this kind of logic gates, then it will be fixed forever. Okay, that kind of arrangement is fixed forever. So it cannot be reprogrammed. Only things that we are able to reprogram, then use a programming language like assembly. So that is something flexible. Okay, but if we combine logic gates and we give to do a certain functionality, it is there and it's forever. It cannot be changed unless we rearrange the logic gates again. Okay.
Okay.
Does this make sense?
Yes.
Okay. So do you know the truth table? Do you know how the truth table looks like?
Yes.
Okay. So do you know that the truth table, the number of truth table is based on the number of inputs, and the number of inputs is based on the 2 to the power of the number of inputs?
No, I didn't know that.
Okay. So again, like I am saying, based on the number of inputs, then we will be having different combinations. So if you have two, so do you know, have you seen something like that before? 2 to the power of 1, 2 to the power of 2.
Yes.
1, 2, 4. So the more inputs we have, then the more combinations that we see here. So if we have 2 inputs, then we are going to see four different combinations of those inputs. Okay, when both inputs are 0, that's a combination. When one of them is 1, that's another 2 possible combinations. And then when both of them are 1s, that's the last combination that is possible. So did you know that before?
Yes.
Okay, so do you know when we have 3 inputs?
It will be 8.
So
8 difference.
So do you notice here that we have eight possible combinations of the input? 1, 2, 3, 4, 5, 6, 7, 8.
Yes.
Is that clear?
Yes.
Okay, that's good. So I decided to start with the logic gates because I don't want to leave it to the last moment. And also, if we keep stepping it, keep taking small steps every lesson, then I believe this will help you also. Okay, so we don't need. So we don't need to go through details here.
I don't think so. No.
Okay, so do you know what that means?
means X.
So X here, when we put a bar on top of A, do you know what that means?
No.
So, okay. So what about that? Do you know that when we write
Yes, I do.
X, that's clear, right? But the Boolean
Yes.
one is not clear.
No.
Okay. So, okay. Actually, it is not part of the IGCSE exam here, but they mention it to make it clear. It's not me mention it, but it is a syllabus. It is mentioned in the syllabus, but it means that it will not enter the exam. They make it only here for clarity. Okay. So when we this is X, the output here. Okay, and that's A, the input. When he put bar on top of A, means that he inverse the input. So when you see here 0 in the inverse, when you inverse it, it become 1. When you see here the input, tell me.
We come 1.
Yes, and then when we inverse the input here, if it is 1, when we inverse it, it becomes 0. So that's
Yes.
why he used A bar. Does this make sense to you?
Yes.
Okay, that's good. So, okay, then what about here? So again, you know the AND gate, okay? And but the more interesting thing that if you notice it, it will always help you actually. That's this actually this part, this portion. Oh, sorry. So does this make sense to you when we say A dot B? So dot here means is multiplication. So
Yes.
A is multiplied by B. Do you understand what that means?
That means that it will always be 0 less than both 1.
Yes. So we need that both inputs to be 1 to get an output of 1. Else it will be always 0. So does this make sense to you? We move forward?
Yes. Okay.
Okay. Yeah, good. Okay. So is that clear to you here? Again, the Boolean side? That
Yes.
for OR gates we use A plus B?
Yes.
Okay, good. And the NAND? So is that clear that why we use a bar?
No.
So NAND gate is not AND.
Okay.
Okay.
Yes.
So not AND means that if AND is A dot B, so NAND means the inverse of that. Okay.
Right.
So if you look at the table of the AND, you will find that we only get 1 at the output at this stage when we have both inputs are 1s. But the inverse of that is that you have 1s all over at all the combination of the inputs except when you have 1s. So that's totally the inverse of what we have at the AND gate. Does this make sense?
Yes. Okay.
Truly?
Answer. Yes.
Okay, perfect. So, okay, again, let's have a look here at the Boolean side. So we say we already know that the NOR, we don't want to remember the NOR. If you remember the NOT and the AND and the OR, okay, how they looks like, okay? So by using logic in your mind, then you are able to know all the remaining gates. NOR is not a NOR, not an OR gate, and NAND not an AND gate. So here, as you see, that's the inverse of the OR.
Okay.
Okay, so we know the OR is a plus, so A plus B in the normal case without the bar. This is the OR gate, okay, which means that anytime we have 1 at any of the inputs, we will always have 1 at the output. But since this is not OR, it means that we will have the inverse of that. So only when both of them is 0, then we have 1 here. Does this make any sense?
Yes.
Okay. That's good. Okay. XOR. Is that difficult? Is XOR? Did you find it difficult?
Yes, I don't really understand.
So, okay. Actually, to me also, when I was young, that also was difficult to me, because it is
Okay.
I mean, it is not like the NAND, it's not like the NOR, it's also not similar to the AND or even to the OR. It's just a strange thing. Okay. But the thing here is that if you see how it is designed, so because it's slightly complicated, it have two possible formulas for the Boolean algebra. They have it. If you look here, you'll find that this is actually so of course we know that this is a multiplication, because any dot is a multiplication and any plus is a plus, just an addition. Okay, so this reminds you of what gate when we have A plus B?
The OR gate.
OR gate. Yes, yes, typical. Yes. And what about that? This reminds you of what gate?
The AND gate.
NAND gate. So it's not an it's okay. So now we have actually a combination of an OR gate and a NAND gate. And we multiply them. Okay, we multiply that. So to be able to reach an output, we have to combine the output from 2 gates. So it means that both of those have to be 1 to be able to reach an output of 1 here, because there is a multiplication, right? So if one of them is 0, then the output typically will be 0, right?
Yes.
Okay, so can we have a simple look here? If we look here, okay, let me see. So if we have, let's have a look here. In this possible combination, we have A0 and B0, okay? So when we have A0 and B0, so the output for the OR is what?
0.
Yes, perfect. And we have dots here, multiplication. Okay. And okay, when we have A0 multiplied by and B also, which is 0, and then we get the inverse of that, then we have what? So if we have both of them 0 like that, and then you inverse that, so what will be the output here? What should we put?
1. 1.
1, yes, perfect. And then when we multiply 1 and 0, what will be the output?
0. Okay.
Yes, 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 yes. Okay, so now let's have a look at this possible combination. When we have A0 and B1, so what will be the result here?
0 as well.
No,
1
wait.
in this.
0 plus 1, 0 plus 1 is 1. So let me, yeah, wait, I need to make this one slightly smaller, else I'll not be able to write here. So yeah, let's see, hopefully. So we have 1 here, for this portion. And what about here? If we have A multiplied by B, multiply A by B, so the result will be
it would be,
so multiply 0 by 1, just a normal multiplication.
Yes, 0.
0. Yes, perfect. Okay, so multiply 1, normal multiplication, 1 multiplied by 0 equal
0.
But wait,
A equals 0.
Okay, equal 0. Yes, okay. But did we? I mean, but we have done something wrong here actually. So again, here, this portion, we said we multiply 0 by 1. If you multiply 0 by 1, normal multiplication, the output will be 0, right? But
Yes.
we have to, we forgot to inverse that. Inverse it means the 0 turns to be 1.
Okay.
So instead of 0 here, we have to put 1. Does this make sense?
But then for the previous one, it says 0 times 1. If the 1 becomes 0, it would still be 0. 0 times 0 is still 0.
And you're talking about this one?
Yes.
Okay. So okay, let's do it again. So you're talking about which part? This part? Or this one? So
both of them.
Both of them. Okay. Again. So A, we have both of them 0, right?
Yes.
Okay. So A 0 plus 0 equal
0.
Perfect. So that is correct, right? That's correct.
Yes.
Okay. What about here? 0 multiplied by 0 equal
0.
And you inverse it?
Yeah, 1.
Yeah. So 0 multiplied by 1 at the end to get the final result? It's not clear?
You get 0.
Clear or not?
But I'm talking about the second row.
You're talking
in
about
the second row, it gets 1. But shouldn't it get 0?
Wait. Okay. So are you talking about this? Sorry, it's let me see here. So are you talking about this combination? Are you talking about the second one here?
Yes, the second one. The one over here.
So which one here? The first or the second?
The one in blue, like that one, the second one. The first one here.
Okay. So again, okay. Can we do it? Okay. Yep. Oh, okay. So, okay. So the first one here, this one.
Yes.
So okay. Now, why you are confused?
Because you said that it was related. You're doing it for this one, but 0 times 1 would give you 0, even though there's supposed to be a 1 here.
Yeah. Yes, but I still don't get why you are confused. But let me think. So I mean, so you see here we have 1, right, and as an output, and this match what we are getting here is not confusing you. I mean,
I didn't. So I thought the second one was connected to the third one.
Oh, just because of the arrow. Oh, I mean, yes, but please bear in mind that both of them will have the same result. But please bear in mind when I reduce the size of the screen here, so my drawing actually is shifted. The arrows is shifted. So so actually, so here. Sorry, I think maybe this is not the correct. So, okay. This actually is not so perfect. What is happening to us here? So I would say, let me try to see. So okay. So do you mind if we do them again? But you tell
Okay.
me. So now we talking about this, the first possibility here, 1.
Yes, okay.
And give me a second, I need to change that color. Okay. So now here 1, 2, 3, and 4. Okay, and let me write text here. It's easier. Okay, now, so tell me, when we have both of them as zeros, so what will be the result from A plus B?
0.
0, okay. And then multiplied by? Here.
1. 1.
Oh, 1, okay, yeah. And then the output will be?
0.
Okay. That's good. Yeah, it's not very clear, but that's our luck. Let's try to have a different luck. Okay, so now for the second. When we have one of them is 0 and one of the B is 1. So A plus B?
It would be 1.
Yes. And multiplied by? A multiplied by B. So 0 multiplied by 1.
0.
0. And you inverse it because of the bar?
1. 1.
Okay, so the result is?
1 is the final result.
Yes. Okay. Okay, we go to the third. Okay. So A plus B?
Also 1, and then
1
times
okay.
1.
So it is the same, right?
Yeah.
Okay, good. Okay, what about the last one? So when you have both ones, A plus B, 1 plus B, so we have to stop now and then we have to enter again. Okay?
Yes, okay.